example problem. This one. Okay, so this example problem has been extracted from the other operations research textbook. I believe is Hillier Lieberman's Introduction to Operations Research book. So in this example, university maintains a powerful mainframe computer for research use by its faculty, PhD students, and research associates. And during all working hours, an operator must be able to operate and maintain the computers, as well as to perform some programming services, okay? And the director of the computer facility oversees the operation. And it is now the beginning of the fourth semester. And the director is confronted with the problem of assigning different working hours to her operators. Okay? And because all the operators are currently enrolled in the university, they are available to work only a limited number of hours each day, as shown in this table. Okay. And there are 6 operators, 4 undergraduate students and 2 graduate students. Okay. And they all have different wages rate because of differences in their own experience with computers and in their programming ability. So basically this table shows their wage rates, right? Here, along with the maximum number of hours that each can work each day. So these are all the maximum number of hours available. And also each operator is guaranteed a certain number of, certain minimum number of hours per week that will maintain an adequate knowledge of the operation. This level is set arbitrarily at 8 hours per day. 8 hours per week, sorry. And for the undergraduate student, and the undergraduate students are identified as the KC, DH, HB, and SC, and 7 hours per week for the graduate student. Those are KS and NK. So these first 4 students are the undergraduate students, and these 2 students are the graduate students. Okay. And the computer facility is to be open for operation from 8 a.m. to 10 p.m. Monday through Friday, with exactly 1 operator on duty during these working hours. Okay, and on Saturdays and Sundays, the computer is to be operated by other staff. Because of a tight budget, the director has to minimize the cost, and she wished to determine the number of hours she should assign to each operator on each day. Okay, so again, you are required to formulate a linear programming model for this problem. And I already provided the decision variable. Okay, so I want you to use x of ij as your decision variable that represents the number of hours operator I is assigned to work on day number j. Okay, and also I provided 4 different sets of constraints you need to consider while building up your LP model for this case. Okay, so let's build the LP model then. Okay, again, I'm going to use Word file. Okay, and I'm going to insert a new page. And I'm gonna move a little bit here. Okay, so let's work on this. Okay, so first I'm gonna restate decision variable. X sub ij is the number of hours operator I is assigned to work on day j. Okay. I. So we have how many operator? We have 6 operators, right? So I will be 1, 2, until 6, right? So where 1 equals KC, 2 equals DH, right? And so on. And 6 equals NK. From this table, okay, in order. It's going to be I. And the J values, how many different J we have? How many J values? J is going to be 5 different values, right? Because there are only 5 working days in a week, Monday through Friday, right? In here, Monday through Friday. So it's going to be 1, 2, 5, right? So of course, 1's going to be Monday, 2's going to be Tuesday, and 5 is going to be Friday. Okay. So that's our decision variable. Now we need to consider our objective function. We want to minimize, right? We minimize the stepping plan. So it's going to be minimize, and we are going to use these wage values, right? So that's going to be basically $10 times what? X11 plus X12 plus X13 plus X14 plus X15, right? And $10.10 times X21 plus X22 plus X23 plus X24 plus X25, and so forth, right? You're going to do that until $11.30 times X65, right? So let's do that. It's going to be X11, right? X12, X13, X14, X15, right? That's for the first operator, KC. But, you know, because the wage for Tuesday and Thursday for operator KC is going to be 0. That means he doesn't work, right, on Tuesday and Thursday. So you don't need to include X12 and X14. Is that correct? Now let's move on to operator DH. DH, you're going to pay $10.10, right? Likewise, you don't need to include 2-1 and 2-3, right? Because he's not going to work on Monday and Wednesday and Friday as well. So we'll only include X22, X24. That's it for the H, right? So continue on for HB. So $9.90. That's going to be wage per each hour. This time X31, 32, 33, and 35, right? 31, 32, 33, 35, right? So let's keep doing this. 9.8. X41, 42, 43, 45, right? Same. Okay. And for KS, $10.80 times X51, X53 plus X54. And finally, NK, 11.30 times X65, 64, and X65, right? Is that all? Okay, that's our objective function. Okay. Okay, so what's the first constraint we need to consider? Okay, the first constraint we're going to handle is going to be maximum number of hours available each day. Okay, that's very straightforward and very easy because here, this table provides all this information, right? That these values shows the maximum hours availability for each operators for each working day, right? So first constraint, I'm gonna just write it down. Okay, let me just copy from here. So the first constraint, I'm gonna use asterisk. So that's the comment. Likewise, I'm gonna put asterisk. Okay, so our first constraint is basically X11 is less than equals 6, X13 is less than equals 6, X15 is less than equals 6, right? And then X22 is less than equals 6, X24 is less than equals 6. Continue on that. X31 is less than equals 4, X32 is less than equal to 8, right? And then you need to do that all the way down to X64 is less than equal to 6. And finally, X65 is less than equals 2. So you need to put them in here, okay? Everything. So X11 less than equals 6. X13 less than equal to 6. X15 less than equals 6, all the way, x64 less than equal to 6 and x65 less than equals 2. Okay, that's what you need to do for the first constraint. Now let's work on the second constraint. Number of hours guaranteed for each operator. Okay, I think if you move down to, okay, second screen here. Okay, down here, we need to consider this information, okay? So for the undergraduate students, KC, DH, HB, SC, the minimum number of hours per week, the working hours per week has to be 8 hours, right? So for example, for KC, how'd you do that? So if you look at the KC, he's the undergraduate student. So X11 plus X12 plus X13 plus X14 plus X15 has to be greater than equal to 8 hours per week, okay? So for KC, it's going to be X11, X12, X13, X14, X15 has to be at least 8 hours per week, right? However, just like we did for the objective function, we don't need to include X12 and X14 because from here we know that KC does not work on Tuesday and Thursday, right? So these are redundant information. So just take this out. Okay, so that's for the KC. If you move on to DH, it's going to be X22 plus X24 is greater than equal to the same number of hours, 8 hours, right? So X22 plus X24 has to be greater than equal to 8. So you need to keep doing that, okay? But for the graduate student, KS and H, you have different number, right? So for KS, it's going to be X51 plus 53 plus 54 has to be greater than equal to 7 instead of 8 hours per week, right? So it's going to be X51, X53, X54 has to be greater than equal to 7. Likewise, NK, another graduate student, X64 plus X65 has to be greater than equal to 7. Okay, so these are the second set of constraints. Then how do you deal with the next constraint? Total number of hours worked each day has to be equal to 14. 14, okay? So what is that? So how many constraints we're going to have for this condition? 5 different constraints, 1 for each working days, right? So for Monday, what you need is X11 plus X21 plus X31 plus X41 plus X51 plus X61 has to be 14. Is that right? So we are gonna put them in here. X11 plus X21 plus X31, X41, X51, X61 has to be equal to 14. That's for the Monday constraint. But again, wherever there is a zero value, we don't need to include this, right? Because we know that DH doesn't work on Monday and NK doesn't work on Monday. So you need to take out X21 and X61, right? So likewise, you can construct one for Tuesday, Wednesday, Thursday, and Friday. So let's do it for Friday, okay? So it's gonna be X16, right? Sorry, it's 15, right? X15 plus X35, X45, X65 is equal to 14, okay? And last but not the least, we need to add the negativity restriction. So Xij is greater than or equal to 0 for all I and j values, okay? So combining all together, this is the complete LP model for this example, okay? Okay, so right now, let's work on LINGO sets, okay? Because Lindo and Lingo without sets would be really straightforward, but let's practice Lingo sets with this example, okay? So I'm gonna use this, but besides the Lingo window, so that I can still reference what it did for LP model, okay, from here. Okay, I'm gonna open the new window. Okay, so we have new Lingo window. Oh, it's very dry. Okay, let me drink water. Okay, so Lingo start with model and with ending mark. So I'm gonna just put this. And as always, we start with defining sets in the sets section. So sets and end sets, okay? Make sure all of these are in blue so that they are the Lingo function name, okay? So in the sets, first we define, let's define the operator, okay? So, okay, I'm gonna use uppercase operator. And how many operators do we have? We have 6 different operators, right? So after slash, you can use 1, 2, 3, 4, 5, 6, or simplify this 1.6, or you can explicitly specify that. So go back to slide, and then I'm going to specify the operator's name, okay? KC, DH, HB, SC, KS, and K. That does work, okay? And after colon, we need to specify the attribute. Okay, so let's look at the model. So, okay. First thing, the set operator associates with the wage, right? Wage rate, the pay rate. And what else? And the minimum number of hours guaranteed, right? Those are the two different numbers, kind of numbers. 8 for the undergraduate student and 7 for the 2 graduate student, right? So we need to have those two attributes. So let's say minimum wages, but you cannot use min because it's in blue. That means min is one of the Lingo's function names. So let's say minimum instead, okay? Minimum, and let's say pay rate, okay? Okay, and what else? We need to define another set. What is that? Day, working day, right? And there are 5 working days in a week. So this time, Monday, Tuesday, Wednesday, Thursday, and Friday. Okay. And the set day associate each with one quantity. What is that? The total number of hours, right? Worked each day has to be 14. So each day, the total number of working hours is set to 14. So we have to put them in here. So let's say that's the required working hours, okay? Okay, so is that it? So far we defined 2 different primitive sets. One is operator, because there are 6 different operators, we have 6 members in the member list, right? And the set operator associates each with these 2 different quantities, right? Pay rate or wage rate, and the minimum number of hours guaranteed for each operator. So we also name it minimum, okay? And we also define another primitive set, day, because there are 5 working days in a week. We have 5 members in the member list. And also this day associate each with the one quantity, because each day the total number of working hours is set to 14 hours from 8 a.m. to 10 p.m., right? So we just named it as required. Okay, so is that all? We actually need one more set to input the assignment, okay? We need to assign each operator to each working day, right? So we need a 2-dimensional table defined on the operators and the days, right? Just like we use in this table. This is two-dimensional table, right? So in this case, we need a derived set. Okay, so let's name it assign. And this assign, this derived set has two attributes, actually. Okay. And this derived set is coming from parent set, which is operator and they. And what attributes we have? One is available. That represents the maximum number of hours that each operator can work on each working day, right? That refers to these, right? These values. Also, the other one is our decision variable, right? So our decision variable is the number of hours operator I is assigned to work on day J, okay, for example. So I believe that's it for the defining the set section. Now we move on to the data section. And we provide the data values, okay? So we need this, right? And we also need this, right? And we need this too, right? So for the minimum value, it's going to be 8,888,77, right? So for the four undergraduate students, 8, and 2 graduate students, the value is going to be 7, right? And the pay rate, we're going to put these 6 different values in order. 10, 10.10, 9.9, 9.8, 10.8, 11.3. Don't forget to close each data value with semicolon as well, and up here as well. Okay, just be careful. Okay, keep in mind that in Lingo, each statement has to be terminated with the semicolon. Okay, and the required, okay, it's going to be 14 for each day, right? And the available, that's going to be all of these table values, right? So let's put them in here. So available is going to be 60606. Actually, you can put 06060 and 48404. But for the easier readability, I'm going to just sort it this way. Okay, but you don't need to. And what is the next column? 55505 30380. And finally, last row 00062, and then semicolon. Okay. Okay, now we are ready to work on our objective function. Okay. So for our objective function is this, right? This is the objective function. So it's going to be minimize okay. Don't forget equal sign before you type your objective function. Okay. So you want to minimize the total payment, right? So it's going to be, how you call it, total pay. And then total pay would be equal to and something like that. Or you don't need to do this, right? Directly you can put the summation sign over there. Summation symbol, I mean. And your objective functions gonna be basically pay rate I times X ij, right? So pay rate is those 6 different values and X ij values. So that's what you need basically. But you remember, for you to use these attribute values, right? Pay rate and X variable, you need to specify the set name first, okay? So in this case, we just need to include a sign. Because in this assign, the same name assign, the operator is already included, right? That's for pay rate. So what you need is include assign inside the parentheses. You just specify subscript ing like that. And then don't forget to close parentheses. That's it, right? So right now, let's check if the Lingo generate the objective function as you planned for. So choose display model, something like that. How's that? This what you are looking for? That's okay. But the thing is, Lingo does include actually it's okay. So it's going to be, well, it's hard to see. I use the numerical value here, but I use the actual operator's name and the actual working days. So it's going to be 1, right? It's going to be x11 and x13, I believe. And no, actually it's x12, right? And x13 and x14. Okay, so okay, that's okay. That's good. That's good. So that I want to include conditional qualifier so that in our actual formulation, you do not include this x12 and x14, right? Because it's redundant information, right? Because we know that the first operator, KC, does not work on Tuesday and Thursday, right? So let's not include this in our formulation. So in the lingo set, what you need is right after this, okay? Right after this name, assign, you need to put the vertical bar. And I just say the available ij is not equal to what? Value of 0, okay? So let me press enter, so you're gonna see that, okay? So now let's see how Lingo generate our objective function. Okay, so this is our new objective function. So compared to the previous one, right now, KC, for KC, there is no Tuesday and Thursday, right? So that's what exactly what you're looking for. Okay, sounds good. So let's get back to our lingo set. Okay, so it looks like our objective function is done, right? And let's now work on our first constraint set, okay? So first constraint set, so let me copy what it did earlier from regular lingo, not the regular lingo, just LP modeling. So I'm gonna just copy paste here. Right now you can see that everything that I pasted here is in green because lingo take it as the comments since is after exclamation mark, right? What is that? Where is our lingo model? Okay, so here. So now we're gonna handle that. So after that, just put the semicolon. And now we are going to handle our first constraint set. So that's going to be, let's say, 4 each day. So J, right? We're going to no. Actually, in that case, we have to use the assign, right? So assign ij, right? Xij is less than equal to available, right? Is that correct? AJ. That's it, right? So again, what you need is this, right? Which is exactly the same as this, right? each xij values has to be less than equal to whatever is available. Okay. However, in order for us to use this available attribute, available and x value, you need to specify is send name first, which is assign. Okay. So that's why we did it here. So let me delete this and let's check if Lingo generate the constraints correctly. Okay, so that's what Lingo generated. Again, you can see that there is some constraints, unnecessary the constraints has been included, right? So, you know, KC doesn't work on Tuesday and Thursday, but it's been included here in the model. Actually, you still can include it, but there is no point to include those, right? It will just increase the size of the problem, the LP model. So I don't want to do that. So like we did earlier in the objective function, what you need is just include this part. Just include this part, right? So right here, after the vertical bar, you need to include this, okay? I'm gonna put down here so that you can see everything clearly. So let's see. Let's regenerate our model. Okay, right now, okay, so if the operators are not available for certain days, then the corresponding, the referencing assignment has not been included here, right? So I think we are on the right track right now. And now let's move on to the next constraint set. Okay. So for each operator, right? Next constraint has to be for each operator. Let's say I. Oh, sorry. We need to sum xij has to be greater than or equal to, what is that, the minimum, right? Minimum requirement, minimum. So those are these values, right? Something like that. We need to match the parenthesis. So, oh, this doesn't match to this, right? Okay. I think, oh, I missed here. It's gonna be here. So that this parenthesis does match this. Okay. So I'm gonna delete this. And again, like we did earlier here, I want to add this logical expression. After the vertical bar, right? So in a way, we can avoid defining and also referencing the assignments in which the operator is not available, right? So I just want to make sure LINGO does generate the constraint set as we planned. Oh, it have. Oh, okay. So what is the problem? We didn't specify the set name here, right? So it's going to be day J. And actually, you need to put this condition right here, right? Okay. So did I correct? Okay, I forgot. Column mark here. Let me double check. Parenthesis, does match. Does match. Okay, let's try again. Choose the display model. Okay, let's see. Is everybody looking for? Yes. Okay, so we have 6 constraints according to 6 different operator, right? And then last 2 operator, those are graduate student. So they do have 7-hour requirement. Other 4 undergraduate student has 8-hour requirement. Okay, and that looks good. Okay, now let's move on to this third constraint. Total number of hours worked each day is 14. Okay, so this time, so instead of operator, we're gonna do this at 4 each day, right? This time. And as sum, this time operator instead of day, right? So we just swap here, down here. So here we have operator I, okay? And after the vertical bar, again, you're going to include this logical condition, right? And then x of ij has to be equal to, what is that? Required j. So this parenthesis match, right? And this match as well. Okay, and then we are going to delete this. So let's double check. generate our math model. So right now, we just added these 5 constraints for each working day, right? So that looks good so far. Okay, now we need to handle this non-negativity restriction. Actually, we don't need to, right? Because both LINGO always assuming that all of the decision variable included in the model, so non-negative, okay? And also takes the real values unless specified otherwise. So I think that's all, right? So let's run the program. So we got the solution, okay? That's the optimal objective function value. And our optimal solutions, all the way down here, these are the x values, right? x11 has to be equal to 2. x12 is 0, of course. x13 is going to be 3, right? Things like that. Okay, so these are our optimal solution value. And later on, when you are talking about the sensitivity analysis, we are going to talk about the reduced cost and also dual prices. Okay, so don't worry as of now. Okay. Okay, so I think that's it. That's all for today. Okay, so I'm hoping that as of now, all of you have some better idea to use both Lindo and Lingo, and even using Lingo sets, okay, to solve any linear programming models. Okay, so hopefully later on for our homework assignment and even for our term project, you can use these optimization solver packages. Okay, thank you very much. So I will see you next time. Bye-bye.